Okay, now we have question number 2, part A, October, November 2012, paper 4, variant 3, another transformations question. And we have this grid, pair of axes. We've got two triangles, X and Y, drawn on these axes, and we're asked to do the following transformations. Bring this up here so we can see what's going on. The first one is a translation of triangle X by the vector -11, -1. So every point on triangle X has to move according to this vector, right? Has to move according to this vector here. Now the vector -11, -1, all right, it, as we know, the top number in a vector represents the horizontal displacement. Okay, so the -11 on the top of the vector represents 11 spaces to the left. And the number in the bottom part of the vector represents the vertical displacement. So the -1 means one space down. So this has to move 11 spaces to the left and one space down. So let's take 1 point from this triangle X, okay, and move that 1 point 11 spaces to the left. Let's just move this out of the way slightly so we can see what's happening, the numbers. Okay, so you've got to move 11 spaces to the left and one space down. Okay, so 11 spaces to the left and one space down. So let's have a look. You're going to go from 11 spaces, so 4 minus 11 is -7. Okay, and then one space down, there we have it. That's the point where this corner will move to. It moves 11 spaces to the left and one space down. Okay, be very careful, as I said before, when you're counting. Sometimes the number of units, like for example, you might have 2 squares per unit. When you're dealing with the vectors, you go by the units, not the squares. In this case, it's 1 square per unit, so we don't have anything to worry about. Okay, so now once we've located the image of this particular point, we can then generate the rest of them without actually using the vectors. We can say, okay, because they're congruent shapes, everything else will be in the same relative position. So for example, the right angle here is going to be 4 spaces to the left of the point we located. So we can just draw a line here, 4 units long. Okay, goes from -7 to -3. Okay, that represents, if we draw it straight, that represents this line exactly here. Now, one of the things doesn't come out in these videos is you must always use a pencil when you are drawing any diagram, in case you make a mistake. Okay, so if you make a mistake, especially when you're doing things like shading and when you're drawing diagrams, always use a pencil in case you make a mistake. When you're writing out your answers in other examples, or when you just got writing to do, of course you use a pen. But when you're drawing a diagram, always use a pencil in case you make a mistake. You can rub it out and then start again. Okay, once you make a mistake in pen in a diagram, there's only one diagram there on the paper for you, and it might have a problem after that. Okay, so be careful. Now, next, okay, I'm going to draw this line. Now I can see that this line goes from 8 to 2, so that's 6 units long. So of course, this line here has to also be the same because they're congruent. So it goes from 7 down to 1. That's 6 units long, and then I can join these two together, and I have copied this exact shape, but I've translated it 11 spaces to the left and 1 space down by this vector as required. So this is the answer to A part 1. Okay, so that's A part 1 done. Okay, that's finished. And number 2, part 2, it says draw the enlargement of triangle Y. Now triangle Y is here, so let me just move this down a bit. Draw the enlargement of triangle Y with center -6, -4, and scale factor 1/2. Okay, so let me move this slightly out of the way, down here, so we can see what's happening. Okay, so center -6, -4, -6, -4. So this is the center of enlargement right here. That's the center of enlargement. Okay, and scale factor 1/2. Now, as I mentioned many times with enlargements, I really much prefer to use vectors when dealing with enlargement. It makes life a lot easier. Although there's lots of ways of doing it and some simple ways, I just like to use vectors. Okay, So, for example, I take the center of enlargement and I find out where a particular point is, from the center of enlargement as a vector. So, for example, this point, you've got to move from -6 to -2, you've got to move 4 spaces to the right. So this particular point, the vector taking you there from the center of enlargement is going to be 4 and 0. You don't move up or down, it's just moving horizontally. And I take that vector and I multiply it by the scale factor, which is a half, and that gives me 2, 0. Okay, half times 4 and a half times 0, 2, 0. So I know the image of this point is going to be 2 spaces to the right of it, because it always start from the center of enlargement. So from the center of enlargement, moving by that vector takes me to this point here. So I know that that's one point on the triangle, okay? And then, for example, the point on this side here, you can see going from -6 to 2, that's 8 units. So it's the vector taking you from the center of enlargement, the vector taking you from the center of enlargement to that point. Just get my pen back so you can see what I'm pointing at. So if it works, yes. Okay, so, 1 second, that's better. Okay, so from the center of enlargement, which is -6, to the point over here, you got to go 8 spaces to the right, and no spaces horizontally, so it's going to be 8, 0. It's supposed to come out in blue. Okay, that's going to be 8, 0. Okay, and you multiply that by a half, that gives you 4, 0. Okay, so from the center of enlargement to our point, we're going to move 4 spaces to the right. So 1, 2, 3, 4, we end up at this point here. So that this corner, okay, will end up going over here. You can see the scale factor is a half, so it's actually becoming smaller. So this line that was 4 units now becomes 2 units, you see? Okay, and to pinpoint the last point, I can even use that factor. I know that this is 1, 2, 3, 4, 5, 6. So this must be 3 units. So I could actually just do that, and I'm confident that I've got the right answer. But you can just make sure, if you want to, you can do the vector that takes you from here to there. It's from here to there. Okay, that's 1, 2, 3, 4, 4 to the right, and 1, 2, 3, 4, 5, 6 up. Multiply that by a half, and you get 2 and 3. 2 and 3. Okay, 2 and 3, you got 2, 1, 2, 3. So we were correct in our assumption. So once you've actually got one point, you can actually pinpoint the other ones by using the fact that the lengths are, reduced or increased by the scale factor. Okay, so if that length was, if I figure out where this point is, I know that the other point in this triangle is 4 units long. In this triangle, it must be 2 units long. So I can actually pinpoint the other points just after I've located one of them. Okay, well, especially when you've got negative scale factors, it's better to actually pinpoint a few of them first. Okay, so here we have your answer. This is the enlargement by scale factor half. Now, even though it's got smaller, it's still called an enlargement, still has that name of enlargement, even though it's got smaller, because the scale factor is less than 1, so it's going to get smaller. So this is A part 2 completed. Okay, and I'll do part B on the next video.